Improper attic wiring poses significant safety hazards. Type NM wiring, often called Romix, requires securement and support using staples, cable ties, or clips. Loose wiring laid on collar ties presents a tripping hazard and risks damage to the wires themselves. Exposed wires between electrical components can lead to short circuits or electrical fires if they contact metal or other materials. Wires should never be run between floorboards, as they are susceptible to punctures, creating potential electrical shocks and fires. The absence of electrical permits, despite claims of professional installation, raises concerns. Firstly, loose, exposed, and improperly supported wiring elevates the risk of electrical fires. Secondly, exposed wires create a shock hazard for anyone touching them or nearby metal objects. Thirdly, loose wiring on the floor constitutes a tripping hazard. To rectify these issues, firstly, all wiring must be properly secured and supported using appropriate methods. Secondly, exposed wires necessitate protection through conduit or other approved means. Thirdly, any wires currently running between floorboards should be removed and reinstalled correctly. Finally, documentation verifying the electrical works completion by a licensed electrician and the procurement of all required permits must be obtained. In regards to securing wiring, cable staples should be installed according to the manufacturer's instructions. Typically, this involves spacing them no more than 4.5 feet apart for horizontal runs and 12 inches from boxes or fittings. When using cable ties, ensure they are listed for use with the specific type of cable and are installed tightly to prevent movement. When considering protecting exposed wires, rigid metal conduit provides the highest level of physical protection. Intermediate metal conduit offers a lighter, yet still durable alternative. Electrical metallic tubing is suitable for dry locations where physical protection is less critical. Flexible metal conduit allows for bends and turns where rigid conduit is impractical. All conduit installations must comply with the National Electrical Code Article 342, 344, 348, and 350. Removing wires from floorboards involves tracing the wiring back to its source and disconnecting it safely. Then, reroute the wiring through approved pathways, such as along joist or through conduit. When obtaining electrical permits, the homeowner or contractor must submit an application to the local electrical inspector's office. The application should include detailed plans of the electrical work to be performed. Inspections are typically required at various stages of the project, such as after the wiring is installed but before it is covered up. Before commencing any electrical work, it is essential to verify that the power is turned off at the circuit breaker. Use a non-contact voltage tester to confirm that the wires are not live. Wear appropriate personal protective equipment, including safety glasses and insulated gloves. When working with wiring, it is important to understand wire gauges and their corresponding ampacities. For example, 14-gauge copper wire is typically rated for 15 amps, 12-gauge copper wire for 20 amps, and 10-gauge copper wire for 30 amps. Always refer to National Electrical Code Table 310.16 for accurate ampacity ratings based on wire type, insulation, and installation conditions. Different types of cables are suitable for different applications. NM cable is commonly used for interior wiring in dry locations. UF cable is designed for underground installations and can be used in wet locations. THH and THWN2 wire is often used inside conduit for both wet and dry locations. The National Electrical Code provides detailed requirements for wiring methods and materials. Article 300 covers general wiring requirements, including protection against physical damage, proper support, and identification of conductors. Article 310 covers conductors for general wiring, including ampacity ratings, insulation types, and installation requirements. Article 314 covers outlet boxes, device boxes, and pull boxes, including their installation and support. When making wire connections, it is essential to use approved methods such as wire connectors or soldering. Wire connectors must be properly sized for the number and gauge of wires being connected. Soldering requires proper technique and the use of appropriate solder and flux. All wire connections must be enclosed in an approved enclosure, such as a junction box. The National Electrical Code specifies the minimum size requirements for junction boxes based on the number and size of conductors contained within them. It is crucial to follow these requirements to prevent overheating and potential fire hazards. Grounding is a critical aspect of electrical safety. The grounding system provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. All electrical equipment must be properly grounded, including outlets, switches, light fixtures, and appliances. The grounding conductor must be connected to a grounding electrode, such as a ground rod or a metal water pipe. Ground fault circuit interrupters are designed to protect against electrical shock by detecting small imbalances in current flow. They are required in locations where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters are designed to protect against electrical fires by detecting dangerous arcing conditions in the wiring. They are required in branch circuits that supply bedrooms and other areas where people may be sleeping. Electrical panels must be properly labeled to indicate the purpose of each circuit breaker. This makes it easier to identify and energize circuits for maintenance or repairs. Panel schedules should be updated whenever circuits are added or modified. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect wiring and equipment from overloads and short circuits. They must be properly sized for the circuit they are protecting. Replacing a circuit breaker or fuse with one of a higher amperage rating can create a fire hazard. When working on electrical systems, it is important to follow lockout-tagout procedures to ensure that the power is de-energized and cannot be accidentally re-energized. This involves turning off the circuit breaker, locking it out with a padlock, and attaching a tag indicating that the circuit is being worked on. Before energizing any electrical circuit, it is essential to inspect all wiring and connections to ensure that they are properly installed and secure. Use a multimeter to verify that there are no shorts or ground faults. Double-check that all equipment is properly grounded. Regular electrical inspections can help to identify potential problems before they become safety hazards. A qualified electrician can inspect your wiring, grounding system, and overcurrent protection devices to ensure that they are functioning properly. They can also recommend upgrades or repairs to improve electrical safety. When purchasing electrical equipment, look for products that are listed by a recognized testing laboratory, such as Underwriters Laboratories or ETL Intertech. These products have been tested and certified to meet safety standards. Avoid purchasing counterfeit or unlisted electrical products, as they may not meet safety standards and could pose a fire or shock hazard. If you are not comfortable working on electrical systems yourself, it is best to hire a qualified electrician. A licensed electrician has the training and experience to safely and effectively perform electrical work. They will also be familiar with local electrical codes and regulations. When hiring an electrician, be sure to check their credentials and references. Ask for proof of insurance and licensing. Get a written estimate before work begins, and make sure the estimate includes all labor and materials. The National Electrical Code is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years by the National Fire Protection Association. The National Electrical Code provides detailed requirements for all aspects of electrical installations, including wiring methods, grounding, overcurrent protection, and equipment installation. It is essential for electricians and other electrical professionals to be familiar with the latest edition of the National Electrical Code. Local electrical codes and regulations may vary from the National Electrical Code. It is important to check with your local electrical inspector's office to determine the specific requirements in your area. Building permits may be required for certain types of electrical work. Check with your local building department to determine whether a permit is required for your project. The purpose of electrical codes and regulations is to ensure the safety of people and property. By following these codes and regulations, you can reduce the risk of electrical fires, electrical shocks, and other electrical hazards. Electrical safety is everyone's responsibility. Be aware of the potential hazards of electricity and take steps to protect yourself and others from harm. If you see something that looks unsafe, report it to a qualified electrician or your local electrical inspector's office. The proper sizing of conductors is paramount to ensuring electrical safety and preventing overheating or fires. The ampacity of a conductor, which is the maximum current it can carry continuously without exceeding its temperature rating, is determined by several factors, including the conductor material, size, insulation type, and installation conditions. National Electrical Code Table 310.16 provides ampacity ratings for various types of conductors based on these factors. When selecting a conductor size, it is essential to consider the load it will be carrying and the ambient temperature in which it will be installed. Higher ambient temperatures can reduce the ampacity of a conductor, so it may be necessary to use a larger conductor size in hot environments. Voltage drop is another important factor to consider when sizing conductors. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. National Electrical Code provides guidelines for minimizing voltage drop in branch circuits and feeders. The type of insulation used on a conductor affects its ampacity and its suitability for different applications. Thermoplastic high-heat nylon conductors are commonly used for general wiring in dry locations. Thermoplastic high-heat water nylon conductors are suitable for both wet and dry locations. Cross-linked polyethylene conductors have a higher temperature rating than thermoplastic conductors and are often used in high-temperature applications. The installation method also affects the ampacity of a conductor. Conductors installed in conduit or cable trays have different ampacity ratings than conductors installed in free air. National Electrical Code tables provide ampacity adjustment factors for different installation methods. When calculating the conductor size for a circuit, it is essential to consider all of these factors to ensure that the conductor is properly sized for the load it will be carrying and the environment in which it will be installed. Undersized conductors can overheat, leading to insulation damage, equipment malfunction, and even fire. Proper grounding is crucial for electrical safety. The grounding system provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The grounding system consists of a grounding electrode, a grounding conductor, and equipment grounding conductors. The grounding electrode is a conductive object that is buried in the earth to provide a connection to ground. Common grounding electrodes include ground rods, metal water pipes, and concrete encased electrodes. The grounding conductor connects the grounding electrode to the electrical panel. The equipment grounding conductors connect the non-current carrying metal parts of electrical equipment to the grounding system. When a fault occurs, such as a short circuit, current flows through the equipment grounding conductor back to the source. This causes the circuit breaker to trip, de-energizing the circuit and preventing electrical shock. Ground fault circuit interrupters are designed to protect against electrical shock by detecting small imbalances in current flow. They are required in locations where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters are designed to protect against electrical fires by detecting dangerous arcing conditions in the wiring. They are required in branch circuits that supply bedrooms and other areas where people may be sleeping. Regular testing of ground fault circuit interrupters is essential to ensure that they are functioning properly. Test buttons are provided on ground fault circuit interrupters for this purpose. The National Electrical Code provides detailed requirements for grounding systems. Article 250 covers grounding and bonding. It is essential for electricians and other electrical professionals to be familiar with these requirements. Proper overcurrent protection is essential for electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect wiring and equipment from overloads and short circuits. Overloads occur when a circuit is carrying more current than it is designed to handle. Short circuits occur when there is a low resistance path between two conductors. Overcurrent protection devices must be properly sized for the circuit they are protecting. The ampacity of the overcurrent protection device should not exceed the ampacity of the conductors in the circuit. Circuit breakers are resettable overcurrent protection devices. They trip when the current exceeds their rated ampacity. Fuses are non-resettable overcurrent protection devices. They blow when the current exceeds their rated ampacity. When a circuit breaker trips or a fuse blows, it is important to determine the cause of the overcurrent before resetting the circuit breaker or replacing the fuse. Common causes of overcurrents include overloads, short circuits, and ground faults. The National Electrical Code provides detailed requirements for overcurrent protection. Article 240 covers overcurrent protection. It is essential for electricians and other electrical professionals to be familiar with these requirements. Electrical safety is everyone's responsibility. Be aware of the potential hazards of electricity and take steps to protect yourself and others from harm. If you are not comfortable working on electrical systems yourself, it is best to hire a qualified electrician. A licensed electrician has the training and experience to safely and effectively perform electrical work. They will also be familiar with local electrical codes and regulations.